Hello, my name is Richard Gillespie. Welcome to my series of videos called Perspectives. These are short videos to discuss various topics that are relevant to today's world to try and put things into perspective. Today we're going to talk about ice ages and climate change, carbon dioxide, and continental drift, and how it all fits together. So let's just start right into it. People are familiar with the fact that ice ages have been happening for the last 2 million years. In fact, 5 million years. If you go back to the beginning of the Pliocene. At the beginning of the Pliocene, the periodicity of ice ages was 40,000 years. And then as it progressed to the Pleistocene, the periodicity became 100,000 years. These numbers correspond to various numbers in the Milankovitch cycles. 40,000 years it corresponds to the obliquity and the angularity of the axis, and the 100,000 year cycle corresponds to how elliptic the orbit of the planet is. And of course, these cycles have been going on since the universe, or since the solar system began. Earth was formed 5 billion years ago, and so these cycles haven't changed since then. So the question is, why do we have ice ages now corresponding to these planetary cycles? So let's start right into that and go back to the beginning of the Miocene. At the beginning of the Miocene epoch, for our purposes, we'll say it's 39.5 million years ago. Antarctica had moved, it was attached to South America, and it moved off to its present position over the South Pole. And Australia broke away from Antarctica, and it moved into the position that it's in now. Once that happened, the Antarctic circumpolar current developed, which is a cold, deep water current going around Antarctica. This set up the ocean currents for the Pacific circulation system, and it drives it today. It's one of the most important currents that we have today. There's no mechanism for warm air or warm water to reach Antarctica, so it froze over, and it's been frozen for since the middle of the Miocene period. We have, along with that, we have the formation of north and south orientation of the major continents. North and South America oriented north and south, and Africa and Europe and Asia also oriented to the north and south. This prevented the normal circulation of seawater currents, which are around the pole, or around the equator, equatorial water flow. Now the water had to flow north and south. It had to flow around South America and up the coast of South America and North America, and then back down the coast of Africa in the Atlantic, and in the Pacific it did the same sort of thing. It went up the coast of Asia and then back down and bumped into South America. And that's known as the Humboldt current, and the current in the Atlantic is known as the Gulf Stream, as people would normally refer to it. And in the middle of the Pleistocene, or the Pliocene, which is roughly, the Pliocene was 5 million years, it began 5 million years ago. We go halfway into the Pliocene. The Isthmus of Panama formed, which bridged off any water flowing from east to west through the gap that had existed between North and South America, or South America and Central America. That closed off, and then that prevented any water from circulating around the equator. This is the most important factor contributing to ice ages. So what happens now is that we have warm water from the south and from the equatorial regions being diverted to the north, where it's cold. In the north we have ice, and as the warm water moves to the north, that water evaporates and condenses as snow, and so we have a steady supply of warm, moist seawater condensing and falling in the north, basically nonstop. And this is the mechanism for building up such huge amounts of ice in the north. Once the north is frozen, there's no evaporation in the north because there's no open water to evaporate. So unless there's some mechanism to bring warm water from the south, you can't get the big buildup of ice. So the most important factor in determining whether you're going to have an ice age is the orientation of the continents in the north-south direction. Now, to look at let's discuss CO2 for a minute. If we go back to the beginning of the Miocene, CO2 was at around 800 to 1,000 parts per million, and it had started to fall quite steadily. And this was it was discovered by Maureen Raymond and her group in the 1990s, that the formation of the Himalayan plateau by the collision of India with Asia raised up the seabed into what is now the Tibetan Plateau. This gave rise to the monsoon rains, because as the hot sun beat down on the open plains, the air currents would rise very sharply, and this would bring in warm, moist air from the surrounding seawater, and this created the monsoons. The monsoons had the effect that they would erode the carbonaceous rocks that the Himalayan plateau was made from, and this removed CO2 from the atmosphere. So there was a strong mechanism for stripping CO2 out of the atmosphere starting in the early Miocene period. And CO2 dropped very sharply throughout the entire Miocene and all the way up until now. So it's been falling precipitously for the last 40 million years. So where do we stand right now with CO2? CO2 is at 410 parts per million, something like that. In the past, it has been a little bit lower, but not much, 380 parts per million during the last glacial maximum. And so it's been fairly steady. CO2 has been fairly steady throughout the past, shall we say, let's say close to 1 million years. Longer than humans have been on the planet. So humans, Homo sapiens, have never seen a CO2 atmosphere of more than about 350 parts per million, 380 parts per million until now, 400, 410. But in perspective, that's still a very low historical value for CO2. What happens with CO2 is that when it is as low as it is, adding any more CO2, you can see a sharp change in temperature, simply because adding some CO2 to the atmosphere it can create an insulating effect. It's actually not an insulating effect. It's a reaction that happens. It releases heat. Some of that heat goes back to the earth, some goes back to the atmosphere. But when CO2 is low and you add a little bit more, you can see a marked effect because we're not at any kind of a saturation level for CO2. But CO2 and temperature are not a linear scale. They're a logarithmic scale. That means that as you add more CO2, the effect on temperature goes down. So as we go up to 400, 450 parts per million, we don't see as big a temperature rise as we saw going from 350 to 400 parts per million. And then as we go higher, the effect becomes even less. So CO2 becomes less of a factor as the percentage of CO2 in the atmosphere increases. So the point of all this is are we experiencing a runaway global warming, or are we just experiencing something that's a little bit out of the ordinary but not too crazy? And the answer to that, if you keep it all in perspective, the Earth's climate is not stable historically. We're living in a very short period of time since the Holocene, 11,000 years ago, where the climate has been stable enough for civilization to exist. Humans have been on the planet for, or let's say Homo sapiens have been on the planet for roughly 200,000 years, maybe a little bit less. So in the entire time that Homo sapiens have been on the planet, the climate has never been stable enough for civilization to evolve. It's only happened in the last 11,000 years. And so should we expect this period of climate stability that we're experiencing right now, is that going to carry on forever? And of course the answer is, if we look back in time, the answer is absolutely not. The climate changes quite severely and quickly on a regular basis, and this is due to ocean currents and other factors, but ocean currents and the position of continents and other geographic or geologic occurrences, such as major volcanoes and things like that, which happen, and cometary or planet or asteroid hits, which have also happened in the time that humans have been on the planet. These things also have had major effects on populations, but that's another video. So should we be worried about CO2 at the moment? CO2 is the most important gas in the atmosphere. If you don't have CO2, you don't have life on the planet. And when CO2 drops below 350 parts per million, the specific pressure of CO2 is low, so low that it'll be very difficult for plants to continue with photosynthesis. We don't have photosynthesis, we don't have oxygen, and we don't have a food chain. So if photosynthesis fails, the entire planet fails. So should we be adding CO2 to the atmosphere? What's going to happen in the next glacial maximum, if we are successful at keeping the CO2 levels low, or we even undertake, as some people would like to do, to physically start removing CO2 from the atmosphere. When we get into the next glacial maximum, which will occur 25,000 years from now, as the ocean cools down, CO2 will be absorbed into the ocean and the atmospheric CO2 will decrease. That will bring it down to levels which are lower than we have experienced at any time in the past in the history of the planet. So we really need to be careful about what we're doing, and keeping things in perspective, we're actually in a situation where CO2 is at a critically low level. Although adding CO2 does make some changes in the climate, and that's because CO2 levels are so low that any CO2 that we add makes a significant change. But are those changes going to be bad in the long run, or are they going to be good? That's, in fact, there's a very strong argument to say that the addition of CO2 is going to be a good thing. The atmosphere has warmed. The planet has warmed, let's say, in the last since industrial times, through basically three basic mechanisms over the past 200 years. First mechanism was the oceans are warming up because of the end of the mini ice age, which began in the 13th century. It ended at the beginning of the 19th century, and the oceans have been warming up until the early part of the 20th century. As the oceans warm up, they release gases into the atmosphere. One of those gases is CO2. So there was degassing of the ocean due to warming of the planet. There has been a warming of the planet due to deforestation, cutting down all the trees. We've cut down all the trees in Europe and North America, and we're well on our way to cutting down all the trees in South America to make way for agriculture. And this has made a marked increase in temperature of the planet. We've also added CO2 through the burning of fossil fuels, and this has also had an effect. So all those things combined, we've raised the temperature, let's say, by the middle of this century by 1.5 degrees. To put that in perspective, the planet is normally at a temperature of 4 to 5 degrees throughout since the let's say the beginning of the Miocene, which is when at that time it was 39 million years ago. Europe and Africa were tropical rainforests, subtropical rainforests. So as things warmed up, the rainforests declined, and then we finally gave way to savannas, and then West Africa completely dried out because of the all of the moisture that's being sequestered away by the last glacial maximum. And this has turned Africa into an unlivable, largely unlivable area, and it continues to be that way. And it will continue to be that way. So where are we headed with this? Are we heading into a climate catastrophe, or should we be as worried as we are? Climate change always happens. Our climate is not as stable as we like to think it is. It has big changes quite frequently through a number of factors, and we just need to keep that all in perspective. And we don't want to completely overreact and start doing things that we're going to regret in the future by, for example, trying to remove CO2 from the atmosphere. There's nothing more ridiculous idea than that. We should be adding CO2 to the atmosphere. Anyway, that's the ice ages in perspective, and climate change, and where the climate's at, why it is where it is, where it's heading. And keep an open mind on this, and be careful about what you accept as being factual. And when people claim to be experts, I'm not claiming to be any expert at all. I'm just trying to take a common sense view of this. And the common sense view for me says 400 parts per million of CO2 seems very low. In fact, it's low enough to be scary. So that's where we are. You may not agree with me. You can add your comments. If you like to subscribe to my channel, that would be great. And you can click on the notifications. And I'll be adding further perspectives on climate change and CO2 as we go. Thank you.